tried so many times. Damn that look in your eyes. Hold me down. Hold me down. Damn it, but don't you know that I will be there? That I will be there.
Projects and show the use cases you have to consider when thinking about transitioning your deployment. And finally, we will give a summary why it's a good idea to transition, and also give you some hints what you can do if you want to try it for your own use case, for your own deployment. Right, why are we here? So perhaps a short game of hands. Please raise your hands. Who is deploying Ceilometer in your deployment? Yeah, quite few. And how many of you are considered? How many of you are kind of concerned about the telemetry project and state of Ceilometry? Yeah, so that's probably the reason why you're here in this presentation, right? The telemetry project has lost many of core contributors, a lot of expertise, and in particular the Gnocchi project, being the recommended backend, is not maintained right now. Another reason for this presentation is perhaps you're looking for a more generic monitoring solution, not just concentrating on OpenStack resources, but infrastructure in general, or you want to collect application metrics. Actually, Monasca can collect any quantifiable measurements to the data store. Perhaps you have a hybrid deployment where you have a Kubernetes cluster, or you run OpenStack on top of Kubernetes, so you want to collect different kinds of metrics. Monasca offering monitoring as a service brings you the possibility to expose all these measurements to the users. Users can push the measurements themselves and can view and organize them, set up their own alerting, and do their own integrations. Additionally, the generic monitoring solution should also offer logging integration. So if you identify some issue in the monitoring, you can jump into the logging and see exact root cause of the problem. And the third reason for this presentation is to encourage cooperation between two projects, Telemetry and Monasca. They have many areas where the functionality is similar. So I think we could and should work together at some points. Right, now I will pass to Joseph.
Thank you. So we wanted to start with a bit of discussion about history for those of you who are kind of new to the projects. Either project, there's some interesting interplay between the histories. And so I'll try to speed through some of this just because we're a little short on time today. But Ceilometer is one of the oldest OpenStack services, going back to around the Folsom release, when it was officially moved from StackForge, where it was being incubated, into OpenStack in 2012. The intent with Ceilometer was to really give you that single point that you could go for data that you needed for billing. Everybody needs to be able to pay for their clouds, and so you need to be able to get your billing data out from your monitoring system. So Ceilometer started out with that focus, but through contributions and additional developments, Ceilometer added support for more features, including event handling. So each OpenStack service is able to publish a notification that becomes an event that can be picked up and captured, but also alarming, being able to notify you if something's going wrong in your cloud. So as these contributions came and as Ceilometer grew in some maturity and began to include more metrics, they also found that as time passed and the samples started to pile up in the architecture as Ceilometer started, it became apparent that the original database backends just didn't keep up. So to try to address that, the telemetry team introduced Noki as a project. It was intended to create a time series database for metric storage, and was designed to be scalable and multi-tenant and platform agnostic. That was an interesting point, and that comes up later. So around that time, the telemetry project also looked at all these contributions that have been given and said, we need to split this out, we need to refactor. So they split out AID as an alarming system, and Panko for event handling. And that happened around the Liberty release. And so all that fell under the umbrella of the telemetry project then. So a little bit more time passed, and then the Noki project, as it was designed to be platform agnostic, also part of their intent was to make it a general purpose time series database. And so they felt like the governance of OpenStack was too stifling for the development that was going on, and so they pushed Noki out into its own open source project, separate from OpenStack in June of 2017. And so that's been good and bad. So some of you that have experience with Ceilometer know that around that same time, the telemetry project also lost a lot of the developers that we had. We've seen this in some of the other OpenStack projects that companies, as they looked at how much contribution they were making, and they tried to right size. And so unfortunately that meant some of the principal developers had to move on to other things. And unfortunately, telemetry was hit kind of hard by that because development on AID and Panko really stopped. The original developers had moved on to other things. There just wasn't support. There's some well-documented stories about that on the web. And unfortunately, this also means that Noki now, as of a month or so ago, it really is hitting an unmaintained state. So it's not all doom and gloom, though. Stepped up project, and they've really tried to step in and continue support for Ceilometer and other services. So a big thank you to them, and encourage you, if you do have vested interest in Ceilometer, to contact the community and be ready to contribute, because I'm sure they would appreciate it. So Monasca has a parallel history here. Monasca actually started back when HP and Rackspace recognized that Ceilometer really had serious performance issues back in 2013. It wasn't keeping up and it wasn't scaling well. And so Monasca and Rackspace got together, said, we can do better, let's work on this. It was first presented to the OpenStack Summit in 2014, and Monasca was placed into production. So since 2014, Monasca has been used in production in a number of clouds. And we've seen some great benefits from that. Logging support was added back in 2015, and Monasca became an official OpenStack project in 2015. Since then, it's continued to roll on and become more mature. In 2017, it was kind of first containerized, and you could run Monasca in containers. And then in 2018, the Cola project actually added support for Monasca officially, which makes a nice way to just roll Monasca into your containerized environment. So.
Right. Let's move to the other part of the presentation, the comparison of architecture, both projects. Let's start with gathering the measurements. As you probably know, there are two types of agents in Ceilometer: the polling agents and notification agents. Notification engines, they consume the OpenStack notifications produced by OpenStack services and then generate samples for storing in the database. The polling agents, they send queries to the individual services and then collect all the necessary information to build the samples. The first ones are preferred because polling agents can generate a significant load on the individual services. And as I said before, Ceilometer just focuses on OpenStack services. It's just interested about the usage of OpenStack services and its resources. Now, for the Monasca, in terms of gathering metrics, the crucial component is Monasca collector. It's part of the Monasca agent. It runs checks periodically, and each of these checks is responsible of gathering some specific data, both from the system as well as from applications and services. So you've got, it's a pluggable architecture, so each check can be added as an individual plugin. We have plugins for libvirt to measure the utilization of the VMs, OVS, Ceph, databases like MySQL or message queues, RabbitMQ, Memcached, and many more. Apart from these checks, we can also collect measurements from the applications which already instrument themselves and provide some measurements. So you can scrape the applications with Prometheus instrumentation. You can scrape the Prometheus endpoints of these applications. You can also send the statsd measurements from the applications which support this to the Monasca statsd component. After all these measurements are collected, they are forwarded, they are sent to Monasca forwarder. Here shortly a list of possibilities how you can extend the Monasca agent and send your own application measurements to Monasca. So the first two are using the instrumentation available in the application itself. It's actually the preferred method because the application itself knows how it works and it has the most flexible way of providing this information. So you can do a statsd plugin to push the measurements to Monasca statsd daemon, or you can instrument the application with the Prometheus client, then it exposes the endpoint which can be scraped by Monasca Prometheus plugin. Then you can use a black box monitoring. This is what most of Monasca agent plugins is doing. So it checks some information about available in the system, or it is actually the similar way how Prometheus, most of Prometheus exporters work. And last but not least, you can send the measurements directly to Monasca API. After the measurements have been collected, they have to be sent to the central storage. In case of Ceilometer, the only officially supported backend till train was Gnocchi. For Monasca, we moved the collected measurements to the forwarder, and its task is to build the batches of measurements, to authenticate with Keystone, and then send the batch of measurements to Monasca API. In case that the API is not reachable for whatever reason, the messages are buffered for some time in memory, so it prevents that in case of some failure you lose your measurements. The buffer is configurable in size, so there is also no no worry that you will run out of memory on the system. Storage metrics?
Pass over to me. So as we collect up the metrics, they have to be stored somewhere. As you're probably familiar, in Ceilometer, as we've mentioned already, Noki is the only officially supported backend at the moment, which is a bit of an issue when it's not supported well. It could be possible to develop other time series backends, but there just isn't anything in the works at the moment. However, with Monasca, we actually use Apache Kafka for managing the message queue. So as these measurements come in, we can distribute them in a very resilient way across our storage. And we have a Monasca persister, which then takes those measurements from Kafka and stores them into our time series database. Currently, we support both InfluxDB and Apache Cassandra as backends, and it's a flexible design, so it would be possible to add your own happy flavor of time series database. Monasca API allows you then to query back out of that database your measurements and statistics about what your cloud is doing. So I mentioned that currently Ceilometer only supports Noki as a storage backend. There's a bit of a caveat to that in that back in 2015, Celosca was introduced. Celosca being Ceilometer plus Monasca. And Ceilometer allows a separate publisher to be introduced. And so at the time, we were able to take Ceilometer metric samples and then publish them over to the Monasca API. It actually had some really interesting implications for that. It kind of covers any gaps if you're trying to move from Ceilometer to Monasca and you realize that one measurement that you really need isn't available in Monasca for some reason. You can get it this way. The latest news on this actually is that just last week, the new telemetry team approved our pull request. So Monasca Publisher is now actually available in Ceilometer. It used to be Monasca, there was a Monasca Ceilometer repository that you would install from separately. But with Usuri, you'll be able to just configure Ceilometer and publish run the Ceilometer client to gather samples and then publish it straight over to Monasca for storage and management. So we're very grateful for the telemetry team approving that. This is just a little bit of an overview of what that looks like. With the Ceilometer agent, there's a publisher interface that passes down through this new Monasca publisher and then can pass into the Monasca API. From the Monasca API, it goes into our storage and can be retrieved back again out from the Monasca API. So there's some advantages definitely that we see in running Monasca. Buffering is really critical. One of the things, if you're running a billing system, you want to know that every sample that you're collecting is being stored properly. And so by having buffering and some resiliency in there, we can handle real world situations where you may have an interruption in your network or just other bottlenecks that you can't foresee. And it improves a bit of efficiency as well because you're not hammering your network constantly. We've seen a lot of scalability come out of Monasca. We can take it up to thousands of nodes, and there's also the great advantage too of just using some commodity storage options and not being dependent on just one backend storage option. So as we talk about this, we would like to help you move from Ceilometer into Monasca. So we've identified a few use cases. But the first thing to be aware of is that there isn't a way to migrate your data from Ceilometer into Monasca. Part of it's just the nature of monitoring data. It's designed around your cloud at that point in time, and so the format that it was collected by Ceilometer isn't the same format that Monasca uses for storage, and so you can't just pull it from one to the other. So our recommendation is if you do want to make this change, one of the first things you want to do is identify when you're making a cutover, do a data dump or do your final reports, capture that data in a way that works for you, and then be ready to move on to the new and better world. So the first very simple use case for that then is just to do new deployment. So anytime you're doing If you're doing an upgrade, that's usually a great time to say, we're moving to a new cloud, we'll do Monasca monitoring instead of Ceilometer monitoring. And there's a few options you have there. Monasca is already, as I mentioned, a part of Cola, so you can just deploy the Cola containers, have Monasca set up, and go from there. You can also deploy Monasca as standalone, and it's well documented in the OpenStack documents. And you can even use DevStack as a guide for how to deploy Monasca in a reasonable way. Along with that, we wanted to point out some of the items you'd want to be aware of as you change your workflows over. In AID, there's a tri-state model, so you have OK, alarm, or insufficient data for any of the alarms that you set up. And so you can either define threshold-based alarms or event-based alarms that happen when some notification comes out. These measurements are then queried out of Noki to determine your alarm states. But when you trigger alarm, you're limited to either a webhook or a log to give you the notification of the alarm. Whereas with Monasca, we actually have a thresholding engine that runs on string processing. We're able to pull those measurements right out of Kafka as they come in. And we have a pretty well-defined, well, I'm a fan, syntax for defining your alarms within Monasca. And this actually gives you some really neat power when we start talking about auto-scaling or self-healing, that you can define an alarm that really fits what you're looking for in those situations. So here's a simple example. We're using CPU utilization percentage, and you can even define a scaling group, which comes in handy when you're doing auto-scaling again. So you can define this set of servers. We want to look at the CPU utilization. We want to take an average over that for your sample window, and then we want to know that that CPU utilization has gone over 50% of your CPU usage. When it says ×3, that doesn't mean 150. It means you have to fail this check 3 times in a row before any alarm is raised. That's really good for debouncing your self-healing or your auto-scaling. You don't want to be spinning up VMs and tearing them down every time something doesn't catch. You want to be able to say, I'm seeing a trend. I'm setting it only at 50, so it's fairly low. You can, of course, set it higher. But you're defining something that relates well to a good behavior that you see. So you scale up when you see a trend going up. You can scale back down when you see the trend easing off. And so then, of course, once you have once an alarm is triggered, you need to be able to send it out. So Monasca has a notification engine that allows you to do that. And we have a few plugins that are already in place. It's a great architecture that we could add even more. And so you can see that we're trying to work with the workflows that operators actually have and be able to reach out to them when a notification is triggered. One of the other interesting features in Monasca is that we can work with your rating and billing systems. So CloudKitty is the official OpenStack rating as a service. If you're familiar with it, it does work with Ceilometer, but it also, a while ago, Objective Libre reached out to us and put in support for Monasca. And this example actually is using Monasca and Ceilometer. It's a pretty simple example. So for instance, your image, based on for this tenant, this image, we've looked at the samples and determined that here's the rate that you need to charge your customers for this time period. And again, so you can do it for images, you can do it for volumes, you can do it for different projects, and it allows you to really break down things in a multi-tenant scenario. There's a great blog post down here too if you need more details about how to set that up. And so as with Ceilometer or CloudKitty, Monasca does not provide a feature that actually reports out dollar amounts. So that's the kind of the final billing piece of what goes on. And we've seen that in the community, almost everyone who's deploying a system that needs to do billing ends up doing their own billing system. So there isn't a one solution to that. And a lot of places will even do their own custom billing. So our focus then, as Ceilometer has also done, is to just make the data available to you. Try to make it easy for you to get to it, and then you can do your billing and run it through your legal and financial departments as you need to. So it's possible not only to integrate with CloudKitty, but you can also just take the data straight from Monasca API, or the Monasca client works well from a CLI or even from a Python integration. And you can pull that data and transform it as you need to. I do have one footnote here. We haven't mentioned Prometheus too much in the presentation, but it is important to note that a lot of people look at Prometheus as a solution for monitoring, but really when you come down to billing, it's just not appropriate. It says right on their website that it's not multi-tenant, it doesn't guarantee delivery, and so please don't base any sort of billing system on Prometheus monitoring. I hope that doesn't sound too negative.
Right. The next use case you probably have to consider and want to consider when you're transitioning is auto-scaling. It is useful for optimizing your resources the users have. Is it VMs or volumes which are used for the application? Efficiently configured auto-scaling is probably part of your deployments. And so Monasca supports auto-scaling with heat, similarly as Ceilometer does. We have resources in heat for alarm definitions and notifications, so we can create an auto-scaling stack in heat, which will automatically generate alarm definition for your scaling scenario and notification for heat. The template is available in the official heat templates repository. If you have some more scenarios, some more sophisticated, please contribute them or share with us. Perhaps we can help with this. If you want to have a step-by-step look how it looks with Monasca, please take a look at the hands-on workshop we held at the last summit in Denver. The material is available in the GitHub repository. Another integration point for auto-scaling could be Zenlin. It could be triggered by webhook notification. We have not used it so far, but we've talked with Zenlin team. It generally there is no technological barrier why it should not work. The next more general scope is self-healing, so strategies around policy-driven behavior to remediate your environment, your OpenStack deployment. Self-healing strategies try to automatically detect failures or some events and perform actions to heal the services. And so we can integrate with such services as Congress for policy-based governance, Vitrage, Heat, or Watcher. When you collect measurements, first what you want to do is to visualize them in the usable form. So it's important to display all your measurements so that you can correlate them with each other to find the root cause of the failure or some anomalies. For that, we implement a Horizon plugin, and we integrate with Grafana, where you can create your own custom dashboards. First, the Horizon plugin. The first item is to give the overview of the state of the system, to list all the alarms and their states in the visual form. The second goal of the plugin is to give the flexible interface for defining alarm definition, so templates for alarms. The Horizon plugin also provides integration with Grafana for metrics and Kibana for logs. Here's some simple example of a dashboard showing the states of the services and memory usage. It's just a simple example. There are much more dashboards which are available and can be done yourself. And last but not least, I mentioned already a few times logging. Monasca provides logging API for multi-tenant logging. It is based on ElkStack, Elasticsearch, Logstash, and Kibana. For the logs collection, we provide plugins for Logstash, FluentD, and Beaver, which authenticate with Keystone and provide tenant information for the logs. In Kibana, we have implemented a plugin for multi-tenancy. It filters the indices in Elasticsearch to show just logs for a single tenant. And the solution is integrated with Horizon. Now, the short summary of the reasons why you should consider transitioning to Monasca. Both Monasca and Telemetry projects provide multi-tenant monitoring, are highly available and scalable. As I said already before, Telemetry focuses on OpenStack services, whereas Monasca is a more generic solution where you can also send your application performance metrics and monitor your services and applications. Monasca provides a delivery guarantee, meaning the messages cannot be lost, which was reported several times in the mailing list in case of Telemetry. Monasca is high performant. We can scale our deployment and couple really high throughput rates via the pipeline. It's also architectural design with Kafka message queue, which is very highly performant. Telemetry has support for OpenStack notifications. That's a part which we are still missing. We have prioritized the development of this and actually have a lot of work done already, but it's not complete yet. You can see our prioritization list. The items are available now for Usuri cycle. Monasca also provides support for logging. And finally, community aspect. Monasca is a small project, but with active community, whereas Telemetry has lost many of its core contributors. A lot of expertise, and Gnocchi as a backend is not supported, not maintained right now. What can you do if you would like to try Monasca for yourself? You can just start with DevStack. We provide a DevStack plugin, so as any other service, the same as Telemetry, you can just install the plugin. Then we have a development environment. It's called Monasca Docker. It's in a separate GitHub repository where we provide Docker Compose scripts to just stack all the components together on a single node deployment. It's more meant for development and testing. And finally, Monasca is fully supported in Kola distribution. As already mentioned, you can install all Kola or just use Kola to install Monasca standalone. If you want to get involved in our community, please use the mailing list or contact us at IRC. Last, some advertisement for our other sessions here in Shanghai. So tomorrow I will be giving a project update. And then in the afternoon, I have another session about monitoring and root cause analysis. And finally, on Wednesday, we have an onboarding session during the PTG. And that's it. I think we still have some time, so please, do you have any questions?
So I see you mentioned Prometheus once. I think I know the answer to my question, but why do you ignore Prometheus? Simply.
So we don't ignore.
Can I answer?
Yeah, go ahead.
We're not ignoring Prometheus. We are actually integrating with Prometheus. So the great value which we want to use is the great community which Prometheus brings, and so many exporters which Prometheus provides. We want to make use of it, and that's why we have a Prometheus plugin in the Monasca agent, so we can collect all the measurements which Prometheus provides already. So publishing to Prometheus, I think we can provide better scalability and high availability than Prometheus solutions do. So that's one reason. Another reason is our architecture with Kafka queue allows us to provide delivery guarantees, which you don't have at Prometheus. Prometheus follows best effort approach when collecting the measurements. If you cannot scrape the metrics, okay, they're lost. Right? It depends on your use case, of course, but in some use cases it is crucial.
Maybe one more really quick one.
I have a question about the agent, the Monasca agent. Is it compatible with Memcached to keep the tokens, the Keystone tokens?
Oh.
Is it compatible with Memcached?
Yeah, Memcache.
Yeah.
No, not specifically for Keystone tokens. It just it makes Keystone calls as needed. So.
But with Memcached, is my experience is performance is better with Memcached.
So MK check is a kind of check for the system. I think we have a plugin for this. I'm not sure. I would have to check.
Sorry, I'm not familiar with that part.
Nowadays we use with Nova, for example,
Okay.
and the performance is better now than before you use Memcached. So I don't know if you think about it.
I'm not sure. I would have to check if we have support.
I'm not sure, but you should ask us again on IRC and we'll look it up.
Right. Sure.
So I see you are from SUSE, and I heard some bad news regarding SUSE's plans. So how can you contribute in the future?
SUSE is, I don't know if you know this, OpenStack, open source first company. So yeah, SUSE is not offering OpenStack as a product anymore, but I am the project team lead, so I have responsibility for the project, and I'm still contributing. And yeah, so community work continues.
Yeah, we still have some big commitments to OpenStack. And actually, if you have deeper questions, Larry in the back there would be happy to talk it through you. Yeah. So. I see the crowd gathering, so I think we're out of time. But Shay, thank you.